Hi folks, Dan from D&N Custom Creations. I want to share with you a little bit of things I've been trying to do to understand how to get better dimensional accuracy on the Langmuir Pro table. And what started the process is I was trying to make some, basically there's hangers for some vice grips and then also some hangers for any of my air tools. And as I cut out the slots, it was primarily the bevel that caused me the problems, where if I ginned up the slot and made it in CAD and Fusion 360 for the right dimensions that I needed to fit the various tools, and then when I cut them out, they weren't the right size. And it was primarily the bevel that's caused me the problem. But in general, I'd like to get a little better understanding of how various parameters like cut height and those sorts of things might affect that dimensional accuracy. And if nothing else, help me to learn how much I need to scale my drawings so that when they actually cut, I don't have to mess around filing and et cetera, which I basically had to do on these two items. So I'm going to walk you through a little bit of things that I'm trying to do. Again, it's to try and help me do better job cutting the crap that I cut out. But I thought, well, if it helps me, then maybe it'll help someone else. So that's what I'm going to attempt to do today. So I'm thinking there might be actually two problems that I've got to correct. Number one is the bevel, because even if I get the right dimension at the cut, let's say I wanted a 1/2 inch slot, and at the top of that cut, sure enough, it's 1/2 inch, but because of the bevel, I'm either greater than a 1/2 inch or less than a 1/2 inch on the other end of the material I'm cutting, in this particular case 11 gauge, then I've got to correct that bevel. And so in the manual for Hypertherm, and again, this is only, it may be different on if you're using something different or even different Hypertherms, I'm not sure. But in my particular case, out of the manual, they're basically showing this diagram that says that, bevel, if I got a negative cut angle, they're number one, then my torch is too low. So if I'm looking like this, where at the top of the cut, I've got my right dimensions, but at the bottom of the cut, I'm bigger, then obviously I'm in this negative cut, and it says, raise the torch, or if you're using torch height control, increase the arc voltage. If you're good, number two, great, that's what we'd all like to see, I think. But the other one is now if it starts out where the height is wider than the bottom, and that's been the case for me, where at the top it's pretty close to that, maybe a 1/2 inch that I desired, but at the bottom it was less than that, so I'd have to get in there with a file or a grinder or whatever and try and straighten out that cut. So my problem has been this number is called, I guess they call it positive torch angle. And they say that the torch is too high. And either lower the torch, or again, if you're using torch height control, decrease the arc voltage. So I made some test coupons that I'm going to use to try and get a better understanding and see if there's other things, like maybe if it goes around a radius and has to slow down to make the cut, do I see a difference there versus, just cutting out a square, etc. So I made this basically test coupon up, very simple. I got a 1 inch diameter hole with a 2 inch square on the outside of that. And then I flipped that around where I got a 2 inch diameter hole with a 1 inch side-by-side square. And then I go to basically what's something that resembles more of what I was attempting to do with my vice grip holders and my air tool holders, where I cut out this pattern and make a slot. So I'm going to do this, and I'm going to vary the different parameters, trying to see if I can correct my bevel problem. And if I get it to the point where the bevel is about as good as I can get it, then that will tell me if I wanted a 1/2 inch and it's less than 1/2 inch, I'll have to scale up a little bit. And if it's greater than a 1/2 inch, I'd scale down the other way. So that's what we're going to play around with today and see what we can learn. Okay, if you've watched my other videos, you've seen how to modify your G-code to put a bunch of pauses in and, kind of look at what pierce height and cut height are doing. So that's what I've done here. So this is supposed to, factoring in all the backlash, etc. now, it should come down and sense the top of the plate and then move to the pierce height, which should be 150 thousandths. And I have a 150 thousandths gauge that when it's sitting there, it's going to pause for 10 seconds, which will give me time to kind of check and see if in fact it is 150 thousandths. After that 10 seconds, it's going to move down. I've set it to 40 thousandths. And so I've got the two feeler gauges that sum up to 40 thousandths, and I'm going to then check and see what the clearance is and make sure that it is actually at 40 thousandths, because I want to verify that I am, when I set something to cut for 40 thousandths in this test cut, trying to understand what nozzle clearance diameter and cut height have to do with the bevel and the dimensional accuracy. I want to make sure that I'm actually cutting at what I think I'm cutting. So that's the whole intent of this little exercise, is to verify that when I do the cuts and set different cut heights, I'm actually where I think I'm at. So the pierce height doesn't really matter too much. It's really the cut height that I'm more interested in, but while I'm at it, I want to go ahead and check the pierce height as well. So I'm going to kick this thing off and then measure and verify that we're getting what we think we're getting. Okay, there it is 150 thousandths, and it's got very little wiggle in there. So sure enough, I'm sitting at about the right height. So here in a few seconds, there's down to the 40 thousandths. I'm sliding a 40 thousandths gauge in. I get a little bit of rub. It might be about 41 thousandths, but it's not too bad. Then it goes back to its free track height, and that's the end. So I'm cutting at the heights that I think I'm cutting. So based on that, then we'll look at what the results are and see if we can understand what the various parameters are doing to bevel and dimensional accuracy. There's been another question in my mind that I've always had. When you look at the charts that tell you the torch to work distance, which we think of as the cut height, when you're using a shielded nozzle, is that the torch distance from the shield or from the nozzle itself? Now the question is, well, maybe that nozzle is flush with the shield and it really doesn't matter. But I've never answered that question before until today, so I'm going to try and do that. Let me blow you up here. So what I've basically done is put a test indicator here with the tip, you can see in the mirror, is right at the center of that nozzle, right where the depression, the little hole is. I'm going to move it slightly away from the hole so it's really kind of the lowest part of that nozzle. And then I'm going to compare that. I'm going to move that out to the edge of the shield and see if there's any difference. The glare is making it difficult to see the test indicator, but we'll try and see if we can figure out what that is. So first I'm going to move it just slightly away from the nozzle. And it has gone from, I had it set on 0, it's gone up to a height of about 6 thousandths. So if we just let that be the reference, that I believe is the distance of the nozzle. And now I'm going to move it out to the edge of the shield and see if it's any different than 6 thousandths. Actually, I'm going to go the other way so it's okay, the edge of that shield looks like 8 thousandths, which means that the torch nozzle is about 2 thousandths less than the shield. So that's probably not going to make any difference. So, I mean, we're we're splitting hairs there. It doesn't really make a difference. So I guess the conclusion from this, based on what we're seeing, is that in the cut charts, when it says torch to work distance, we're gonna just say whether it's the nozzle or the shield, it really doesn't matter. It's the distance, and so we can measure from the shield. All right, thanks. So obviously, before you start chasing down a bevel problem due to cut height and that sort of thing, you probably ought to verify that your torch is vertical. So let's see what we're sitting at now. I'm at 89.8. So that's 0.2 degrees off of vertical. Let's see what we are, make sure that this direction we're good too. There we go. 89.3. So I'm gonna call that good. So we can assume that the bevel problem is not caused by the torch angle. So let's go on to the next step. Well, I think we've all seen enough plasma cutting going on that I'm not going to bore you with that. But I just wanted to show you, this is the 11 gauge piece that I've cut those coupons out. And again, they're done in threes, the square, the circle, and then that, I'm not sure what to call that geometry shape. And so I do that, at different cut heights. I've changed some other parameters there. You see, I got a little close on that, but I still have a couple edges on the other side that I know are good that I can use to measure. So I have now done that four times. The first series was done with a 60 thousandths cut height, and there's a parameter in there that I've been talking to folks on the forum, etc. This nozzle clearance diameter that you'd use when you set up your torch, and I'll show you a screenshot of that. But Langmuir says to set that at 1 inch. Now, if you go and look at the Fusion 360 and try and understand what that setting is for, it implies that it should be a whole lot less than 1 inch, regardless. Now, I had someone on my channel tell me that when they changed that from 1 inch to 1/8 of an inch, that their dimensional accuracy improved. So the first one here is set with a nozzle clearance of 1 inch and a cut height of 60 thousandths. The second one is again 60 thousandths, but I've changed that nozzle clearance diameter to what the gentleman that replied to my one of my videos, where he said use 1/8. I set that to 1/8. So that's the difference between the first two set. Then I go to lowering that nozzle clearance. Since my bevel was that positive angle and it said the torch was too high, I moved it to 50 thousandths, and then the last cut here to 40 thousandths. I may do one more at 30 thousandths to see if I can't go from, go to that other end of the spectrum, which is the negative bevel, and that would tell me that the torch is too low, and I'd know that somewhere in between then is where I want to be. I thought I'd go ahead and show one that the last one I'm going to do, it's at 30 thousandths cut height, and I don't know if I want to try and get any closer to that. I'm also going to hold down on the plate to make sure that there's no rebound. Here we go. I'm going to do one final cut at the 30 thousandths because I want to look at the torch height control and see what it's doing throughout that cut. So here we go. going to show you some of the results here. I'm going to just walk through a little bit of what's here on the table, but I'm going to put the data in a little more of a tabular form so we can discuss it a little bit more and see if we make some conclusions. What I want to point out, here is the items that were 60 thousandths cut height with a 1-inch nozzle diameter clearance. And again, I need to show you where that is in the Facebook manual. Same 60 thousandths, but with the nozzle clearance now down to 1/8. Ignore these bevel numbers now. Those were originally when I was trying to hand measure, and when I used my digital protractor, I got a little more accurate. But then I go to 50 thousandths cut. I go back to nozzle clearance of 1 inch for the rest of them, because I didn't find that taking it down to the 1/8 made any difference in my particular case. But so there's 60 thousandths, then I go 50, 40 thousandths, 30 thousandths, and I actually did one more that I didn't talk about when I was doing the cuts and stuff. I actually went down to 20 thousandths. And we'll look at the bevel edges on each one of those. We'll look at the dimensions and see if we can't come with some kind of conclusions. Now, I will mention that when I used the digital protractor, I measured all 4 sides. There were a couple sides that it was a little difficult, but I think I got a reasonable estimate. And then I visually looked at the edges, and I don't know if I'm going to be able to show you. I don't know how close I can get before this thing, starts looking bad, but you can see the bevel on that. Now that's the 30 thousandths. That should have been well within where we want to go. Now the 20 thousandths, it actually flip-flopped. I wound up going in with a positive bevel. We'll talk about that. I'll try and get a little bit better close-ups. So I think I've gone from the range of the negative bevel to, it didn't actually go flat. It looks a little bit of a, I don't know if that's concave. Yes, concave shape to it. And then I go back to the negative bevel. So I'm going to end it here. I'm going to put things in a tabular form, and I'm going to come back and we'll see if we can't reach some kind of conclusion. Let me show you the how I'm going to attempt to measure the bevel angle on these things. I'm going to use only the square pieces because I'm going to just assume that the bevel is the same for all of them. If it really is a function of torque height, shouldn't matter whether I'm cutting circles or whatever. But so I'm going to put it in a vise like you see here. I'm going to take an accurate digital protractor, and I'm going to set it up on the edge, and I'm going to zero that out. Then I'm going to try and put the protractor on this edge and attempt to balance it so that my hand is not influencing it. And then unfortunately it's upside down, but you see that says 84.6. So if that was a zero bevel, if that was straight across, then that should say 90 degrees. And so if we just subtract that, then that's 5.4 degrees of bevel. And I will do that for each of the different cut heights, and then we'll come back and look at what those findings are. But I just want you to see how it is that I'm measuring that. Let me try a different edge just for the heck of it. That's the one where the pierce was, so that's not going to be a good one. But let's verify first of all that we're still, well, it's pretty good, but I'll go ahead and zero it out. And then we will see, actually if no, it's not going to matter which way I do it, for the numbers are still going to be upside down. Well, you see that's a different number. That's 82.7, which would mean that's a 7.3 degree bevel angle, which is interesting. So I guess what I'm going to have to do, I'm going to have to measure at least 2 of the 4 sides, probably all 4 sides, and see if we can't understand what's going on. But I'll do all of the measurements and try and tabulate it, and we'll see what the results are towards the end.